Semiconductor X is made by doping germanium with arsenic, and Y is made by doping germanium with indium. Two are then joined as shown in the figure. What is following? Which of the following statement is correct? Germanium is doped with arsenic. Germanium doped with arsenic is N type or P type? Germanium doped with arsenic is N type or P type? Arsenic, antimony, bismuth, phosphorus, they give N type of substance. X is doped with arsenic, that means it is N type. Gallium, aluminium, indium, boron, they are P type. P type. Now this is N, this is P, and connected as shown. So X is N type, Y is P type, and junction is which biased? N is connected to negative terminal, P is connected to N is connected to positive, P is connected to negative. This is called which bias? Explaining till X is N type and Y is P type was difficult. उसके बाद तो easy है ना? N connected to plus, P is connected to minus. This is which type?
Reverse biased.
Reverse biased. Solve. This is reverse biased. Correct. So option D. Seventeenth. A 2-volt battery is connected across point AB as shown in the figure. A 2-volt battery is connected across point AB as shown in the figure. This is 10 ohm. This is reverse biased mode connected with 10 ohm, and 2-volt battery is connected as shown. This is the diagram, 2-volt battery. Assume that each diode, the figure given below. Assume that resistance of each diode is 0 when forward and infinity when reverse, then current supplied by the battery when it is positive terminal is connected to A. Which one is forward in this? First wala, second wala, or both? Which is forward in this? Both or first, second? Hello? Which is forward? First one, second one, or both are reverse? This symbol means this one is P, this is N, and when P gets connected to positive, N gets connected to negative, then it is called forward bias. So now tell me, first is forward, second is forward, both are forward, both are reversed.
First is forward.
First is forward. फर्स्ट इज फॉरवर्ड मतलब इसका रेजिस्टेंस है 0 और इसका रेजिस्टेंस इंफिनिटी मींस ओपन सर्किट एंड दिस इज 2 वोल्ट कनेक्टेड रेजिस्टेंस इज 10 फाइंड करंट so I is voltage upon resistance 2 upon 10 equals to 0.2 ohm 0.2 ampere 0.2 ampere completed 17th also done na 18th current in the circuit shown below is this is one PN junction diode 300 ohm. Here it is P and this is N. This is -4 and this one is -1. What is current through this circuit? Ashwin, can you hear me? Hello, Ashwin? Ashwin, can you hear?
Yes, sir.
Current will flow only when forward biased. So, current flows when forward
Bias.
biased. Is it forward or reversed?
This is minus 4.
See, this is negative. This is negative.
So this is forward.
No. P side is at lower voltage. Na?
Yes, sir.
So that means it is reverse biased.
Ha ha.
Positive gets connected to low voltage and negative
Ha.
connected to high voltage.
Right, sir. Right, sir. Ha.
That means this circuit is reverse biased.
Reverse biased.
See, don't check it negative, both negative. ये low मतलब negative होता है. So not necessarily every time plus minus. P is connected to low voltage, na? As compared to N. See, N is also negative and P is also negative. But P is more negative, na? Hello?
Yes,
P is connected to low voltage, N is connected to high voltage. Therefore, it is which bias? Reverse. If reverse bias, what is current flowing? 0. So I is 0 during reverse bias is the answer. Say forward means P is higher, N is lower. And reverse means P is lower, N is higher. So P low, N high, it is reverse bias. Therefore, no current will flow through the circuit. Okay? Whichever part you can't recollect, please tell. So थोड़ा मैं रफ में समझा दूंगा. Because blindly if you copy, then there is no point. I can just deliver the lecture, take the recording and send you. So you should understand that is advantage of live lecture. Completed 18th, write properly everything reason. This is the chapter where you all maximum student lose the mark because it is theory based. Done? Yes, Kamya, done.
Yes, sir.
But you followed the concept फॉरवर्ड रिवर्स का.
हाँ.
कुछ कॉन्सेप्ट नहीं है. पी वाला हाई रहता है, एन वाला लो, खत्म. यही फॉरवर्ड.
हाँ. हाँ सर.
19 देखो. 19 ना. आज मैं आपको आप लोग को मंडे के लिए व्हाट टू प्रिपेयर एंड कम आई विल टेल, सो दैट यू आर नॉट कॉट unnecessary, unaware. This is P N N P battery. P N N P join together. Here there is battery. N P N P. This is the third battery. Plus minus plus minus plus minus. Now I'm reading. Two PN junction can be connected in the series by three different methods, as shown in the figure. If the potential difference in the junction is same, potential difference across junction is same, then correct connection will be which one? Circuit 1, circuit 2, 2, 3, 1, 3 or only one? पहला meaning समझ लो इसका. Viti, can you hear?
Yes, sir.
The question is potential difference across junction is same, then it is first वाला, second वाला और third वाला, और ऐसा combo दिया है. Now Kanav,
हाँ सर.
when forward biased, so when forward biased, then potential difference across junction will be negligible ना, because current flow होने लगता है, नहीं तो barrier potential होता है. Forward biased, potential difference across junction is negligible, and when reverse biased RB, then potential difference is greater across junction. We want किसका potential difference same है. अगर सबका सब रिवर्स बाय है तो सबका सब सेम आएगा, सबका सब फॉरवर्ड है तो सेम आएगा. तो जो भी फॉरवर्ड है उसका पोटेंशियल डिफरेंस सेम, नेग्लिजिबल. जो भी रिवर्स है उसका सेम, अलग है तो डिफरेंट होएगा. फर्स्ट वाला देखते हैं कौन सा बायस्ड है जंक्शन. दिस इज विच बायस दिस जंक्शन, कैन यू टेल मी? फर्स्ट सर्किट में ये कौन सा बायस्ड है? फॉर बायस
फॉरवर्ड.
फॉरवर्ड. यस, वेरी गुड, फॉरवर्ड है. और ये वाला जंक्शन
रिवर्स.
रिवर्स बायस्ड. Forward because P is connected to P, reverse because here N gets connected to this. In this case, second one, what about this junction? Forward biased, huh?
Yes sir.
And this wala junction?
रिवर्स.
मैंने शायद
फॉरवर्ड.
एक डायग्राम पे से ना. This is P and N. P N. So this is negative forward biased. अभी ये फॉरवर्ड बायस्ड है, मतलब इसका दोनों का वोल्टेज सेम है ना जंक्शन का, क्योंकि दोनों सेम ही बायस्ड है. हेलो हेलो हेलो. होता है फॉरवर्ड मतलब दोनों जंक्शन सेम वोल्टेज. थर्ड वाला देखो, रिवर्स बायस्ड, ये भी रिवर्स बायस्ड, मतलब इसका भी वोल्टेज सेम. सो सेकंड एंड थर्ड का जंक्शन वोल्टेज सेम. इतने ही है कि इसका वोल्टेज डिफरेंस कम होगा, नेग्लिजिबल, इसका ज्यादा होगा. हियर डिफरेंट, वन इज फॉरवर्ड, अदर इज रिवर्स. अंडरस्टूड कॉन्सेप्ट, बहुत इंपॉर्टेंट कॉन्सेप्ट. यस, वर्णो, यू फॉलोड?
सर.
In first case, one is forward, one is reverse. So junction cannot be same. Second case, both are forward, both the junctions are same. Both are reverse, both the junctions are same. So in circuit 2 and 3, we can have potential difference in the junction same. So 2 and 3 is our answer. In circuit 2 and 3. Circuit 2 and 3 is given in option B. Anybody who has not followed, कुछ भी rocket science नहीं है. Though forward bias same voltage, the reverse bias same voltage. But in first circuit, we can see one forward, one reverse. They are different voltage. Second, both forward, same voltage. Third, both reverse, same voltage. But second का same और third का same नहीं. बस इतना ही. Okay? Hello?
Yes.
Yes, sir.
हो गया? रब करूं? Yes, can I clear this?
Done, sir.
Okay. Sum number 20. Sum number 20. Which one is reverse biased? Which one is reversed biased? 10 volt and this is 15 volt. Is this reverse biased or forward biased? They are telling which one is reverse biased. A वाला ऐसा डायग्राम दिया. P N फॉरवर्ड है क्या रिवर्स है? क्या सोच रहे हैं? कुछ समझ में नहीं आ रहा है मुझे.
Forward.
फॉरवर्ड है ना, क्लियर दिख रहा है ना. P हाइयर है और N लोअर. B हम लोग को रिवर्स पता लगाना है. 10 वोल्ट.
सर C होगा ना?
एक मिनट लाइन से जाते हैं.
ओके ओके.
इसमें ये क्या है? फॉरवर्ड है क्या रिवर्स है?
Forward.
This is also forward bias because P is connected to higher, N is connected to lower. Forward. They don't make mistake of checking negative. दो नेगेटिव है, उसमें ये हाई हो गया और ये लो. तो आप ऐसा याद रखना इलेक्ट्रॉनिक सर्किट. P मतलब हाई, N मतलब लो. Not necessarily plus minus every time. What about this one? This is grounded and this is minus 10 PM. Tell me now. Hello? Clear दिख रहा है ना? P low, N high because N 0 है. Hello?
Reverse.
So this is reverse. This is our answer. D वाला भी चेक कर लेते हैं क्या है. ये -5, ये +10, तो वापस ये हाई, ये लो, मतलब ये फॉरवर्ड. तो सी अपना रिवर्स बायस है ना. सी इज रिवर्स बायस. Done. Twentieth completed.
Yes, sir.
Number 21. The barrier, potential barrier of 0.5 volt exists across PN junction. Barrier potential of 0.5 volt is across PN junction. If depletion region is, distance of that depletion region is 5 into 10 raised to minus 7 meter wide. the intensity of electric field equals to electric field intensity. Therefore, N is positive because it has lost electron. P is negative because it has lost positive volt. So there is field from positive to negative. And electric field intensity is potential upon distance. Potential is 0.5. Distance is 5 into 10 raised to minus 7. So this is 0.1 into 10 raised to plus 7. That is 10 raised to 6 volt per meter. 10 raised to 6 volt. First answer. 8. Completed?
Yes, sir.
Next one. If no external voltage is applied, if no external voltage is applied across PN junction, then अभी मतलब क्या है इसका देखो. This is P side, this is N side. When no voltage is applied, that is called unbiased condition. When no voltage is applied, then N side diffuses with negative electron of N side diffuses with positive hole on P side. So P becomes negative and N becomes positive. There exists electric field in the space. So they're telling if no voltage is applied across PN junction, there will be an electric field pointing from N side to P side across the junction. Correct? Na? A is correct. If no voltage applied, there will be field from positive to negative. N is positive and P is negative. See, don't mistake again. N is not negative. N was electrically neutral. P was electrically neutral at the start. Join किया तो N का negative और P का positive मिलके diffuse हो गए. So N has lost electron becomes positive. P has lost positive hole becomes negative. So there is electric field between positive to negative. Therefore, answer A. Next case, 23rd. First diode, second diode, a full wave rectifier along with input and output waveform is as shown in the figure. The contribution from diode 2 is which one? This is input. So we get output here, output here, output here, output here. This is P, Q, R, S. They are telling second वाला diode का output कौन सा है? तो first one कभी work होएगा जब first is positive signal. So this is for first one, this is for second one, this is for first one, this is for second one. So who is giving output for second diode? Q and R. sorry, Q and S, QS becomes output due to second one because they are working when second is positive and first is negative. तो first को ऐसा मिला, इस पे वर्क होएगा, इस पे वाला second वर्क होएगा. So Q and S will give proper output which resembles to second वाला. First is P, second is Q. First is R, second is S. Twenty-fourth. In the diagram, input is across terminal A and C. In the diagram, input is across terminal A and across A and C there is input and output is across B and A. So across this you are having alternating source and across this we want output. Suppose I imagine load resistance connected here. Then output is what? अभी देखो जब ये पॉजिटिव होएगा तो वो टाइम पे ये भी पॉजिटिव होगा. So both will conduct current like this. This will conduct the current through this load resistance. ये ऐसा करंट जाएगा, ऐसा जाएगा, ये ऐसे जाके ये सर्किट में फ्लो होगा. वो टाइम पे ये दोनों काम नहीं कर रहे हैं. But when other two are forward biased, these two, when these two becomes forward biased, तो करंट ऐसा फ्लो होएगा. इधर से आएगा करंट, ये फॉरवर्ड बायस्ड है, इसमें जाएगा, फिर ये फॉरवर्ड बायस है, इसमें जाके ऐसा. So what you can say, current is flowing for both the half cycle of input. So this is behaving like full wave rectifier. Okay. Hello? Hello? Have you followed what I said? Have you followed what I said?
Yes, sir.
Okay. Twenty-fifth. In light emitting diode, light is emitted due to recombination of electron hole pair at p-n junction. Due to transition of electron from lower energy to higher energy state. Formation of electron hole pair at p-n junction. Reverse biased p-n junction is wrong. से लाइट एमिटिंग डायोड का मैंने आपको थियरी नहीं कराया, तो आपको एक थोड़ा सा बता देता हूं व्हाट हैपेंस इन लाइट एमिटिंग डायोड. द लाइट इज एमिटेड व्हेन द इलेक्ट्रॉन goes to valence band. That means it goes from high to low. So transition from low to high nahi, it is recombination of electron hole pair. Electrons are free and hole is in the covalent bond. So by recombination, it emits extra energy and light glows. So 25th ka B. 26th. For obtaining maximum power from solar cell, it should be operated in any portion? No. It should be operated in any portion of VI characteristics. ये मैं आपको ये दो बाकी है समझाने के लिए. एलईडी एंड सोलर सेल बता देता हूँ बाद में. 27th. Solar panel is सीरीज पैरेलल कॉम्बिनेशन ऑफ सोलर सेल, मतलब एक सोलर सेल, दो सोलर सेल, ऐसा बहुत सा सेल एक साथ रहता है in row and column. That means it is in the form of series and parallel combination. It is in the form of series parallel combination. That is called solar panel. That's why rectangle shape रहता है, अगर ध्यान से देखा रहेगा. Solar cell converts what? Electric into light? No, it converts light into electric. Light energy into electric. P. 29. A heavily doped diode showing the property of reverse saturation current is termed as Zener, solar, transistor, LED. Reverse saturation current is termed as heavily doped, high reverse saturation current is termed as. अब ये वाला शायद आपको मालूम नहीं रहेगा, because Zener diode is omitted from the syllabus. नहीं तो आंसर लिख लो, it is called reverse saturation current is Zener diode, but it is eliminated from the syllabus, so I didn't taught. Even for CBSE it is omitted. Zener diode in a semiconductor occurs when Zener breakdown occurs when reverse biased voltage exceeds certain value. एंड में सिखा दूंगा. 31. In a general purpose diode, avalanche is more common than the breakdown because 11th में था, because avalanche is lightly doped. So avalanche breakdown is more. एक मिनट, दो टाइप का ब्रेकडाउन है. एवलांच मतलब हेवीली डोप, तो खिसकने स्टार्ट होता है इलेक्ट्रॉन, और लाइटली डोप रहेगा तो टकराना चालू होता है. सो देयरफॉर इट इज कोवेलेंट बॉन्ड बिकॉज it is heavily doped. So covalent bond ruptures. 32. When Zener diode is used as voltage regulator, first of all it is reverse biased. So third वाला case है reverse biased and parallel with the load. Zener diode का part you have not done. I will be explaining you at the end only for entrance. So second parallel with load and third in reverse biased. Second and third is given in option B. Now onwards you have done 33. Oscillator is a device which will convert DC into AC. That is called oscillator. DC into AC. 34. When NPN transistor is used as an amplifier. 34. When NPN transistor is used as an amplifier, NPN transistor is used as an amplifier. This is emitter, this is base, this is collector. So one is forward biased, other is reverse biased, if you are remembering. So electron goes from emitter to the base, then to the collector. Electron move from base to the collector. No, electron is moved from collector to the base. Hole move from emitter to the base. Hole move from base to collector. No, electron moves from the base to the collector. Goes from base to the collector. A option. Electron moves from emitter to the base to the collector. Can I clear this? डन ना? $35 द फेज डिफरेंस बिटवीन इनपुट आउटपुट इन कॉमन एमिटर सर्किट। याद है क्या किसको? व्हाट वाज फेज डिफरेंस लिखाया था मैंने आपको, फिर बताया था VCC इज ICRL प्लस VCE, देयरफॉर डेल्टा VCC इज ICRL प्लस डेल्टा VCE। अगर याद है तो किसको? एक बार और देख लो, ट्रांजिस्टर एंड एम्पलीफायर का सर्किट। Alternating source which is to be amplified is superimposed along with base emitter voltage. This is earthed. Thus, varying voltages between base and emitter. Hence, varying current flows through the base. Then this was load resistance RL connected to VCC. And here we have output between collector and emitter. Current flowing is delta IC. So we said one minute. The alternating source which is to be amplified is superimposed along with base voltage VBB. Hence, varying base emitter voltage is connected to the circuit. Hence, delta IB is varying, which produces varying current IC. Because beta is IC upon IB, since it is greater than 1, so current IC is greater than IB. Hence, we said current gain is obtained. Then for voltage, I told VCC is like battery giving voltage to load resistance, and whatever is left out is between collector and emitter. So delta VCC is delta ICRL plus delta VCE. But I said कि VCC battery का voltage is fixed. Fixed है इसलिए change will be 0. So 0 equals to ICRL plus VCE. So एक example दिया था. This means if VCC is 20, ICRL is 10, 10. So 10, 10. This means if this is becoming 11, this will become 9. But there is no change in VCC. When this becomes 11, this will become 9. तो आपस में अदला बदली करते हैं, but VC is not changing. So delta VCE is minus ICRL. Negative sign indicates there is phase shift of 180 degree. मतलब क्या है, वापस एक बार 180 का फेज शिफ्ट फिर से एक बार मीनिंग. If this is VBB, we connect with VS, which is alternating in nature. तो दोनों का result will be, suppose I told this is 5, this is 0, 1, minus 1 का range. So 5, 6, 4, 5, 6, 4, this is our delta VB. So when this crest goes to the circuit, IB increases, IC will increase, so ICRL increases. If ICRL increases, then VCE will decrease. Same way जब ये negative side पे जाएगा, ये positive. So this is our input, this is our output. What we see, there is phase shift of 180. Hello? Hello? Hello?
Yes, sir.
कुछ क्लियर हुआ कि फिर से बताओ?
सर एक बार आप
हाँ, एक बार और. ठीक है, पहले आपको मीनिंग समझा देता हूँ क्या होता है फेज शिफ्ट. फेज शिफ्ट मतलब एक क्रेस्ट दूसरा ट्रफ, तो फेज शिफ्ट होता है. दोनों क्रेस्ट ट्रस्ट इधर भी वैसे ही, तो नो फेज. ये मीनिंग. अपना VCC क्या है, ये देखो, ये मैंने जैसा डायग्राम बनाया था वैसा बनाया तो नहीं तो आपको कंफ्यूजन हो जाएगा। मैंने आपको ऐसा डायग्राम बताया है। दिस इज एमीटर, दिस इज बेस, इज कॉल्ड कलेक्टर। ये कनेक्ट किया था डीसी से। याद आया सर्किट का लेफ्ट राइट हैंड साइड? याद आया क्या सबको ये डायग्राम? ट्रांजिस्टर एंड एम्पलीफायर वाला है। याद आया डायग्राम? हेलो, ये राइट साइड इज अवर आउटपुट, तो ये वीसीसी किसको वोल्टेज देगा? इसको देगा, प्लस इधर से इसके बीच में रहेगा ना ये पूरा, बराबर ना? अरे यू आर नॉट श्योर।
हाँ सर।
वीसीसी होएगा आईसी आरएल प्लस वीसी, बट ये बेरिंग नेचर वाला है इसलिए डेल्टा वीसीसी is delta ICRL plus VC. This is fixed because ये बैटरी वेरिएबल नहीं है, so no change. That means delta VCC is zero. कौन आ जाता है बीच बीच में और कौन गायब भी हो जाता है? Come to the phase shift part. This was last part which I was showing. So I said VCC is fixed, therefore no change. ICRL plus delta VCE. So इसका concept क्या है? No change, but these two are changing. So I said just example, if VCC is 20, ICRL 10, VCE is 10, so no change. Now this is not changing. So if this becomes 11, this should become 9, then only this will not change. Na? Or if this becomes 12, this should become 8, then no change. So delta VCC change in will be 0 and vice versa. Ye 9 to 11. Then I told, suppose this is base voltage 5 का. इसके साथ superimpose we did of that signal voltage. Then it becomes 5 6 4 ऐसा जा रहा है सर्किट में. So when this is becoming VBE plus VB plus this becoming increases, then IB is increasing, so ICRL will increase. But when ICRL becomes 11, then VC will decrease ना. तो ICRL अगर करेस्ट है तो VC ट्रफ है, मतलब ये अगर 1 से बढ़ गया तो 1 से कम. तो व्हाट इज फेज शिफ्ट? 180 डिग्री और नॉट? So phase difference between input and output voltage of common emitter circuit is 180 degree. Answers. 36. Current amplification in common emitter is 99. Beta is 99. If input base current is 20 microampere, then current through emitter will be how much? I feel कि इस पे आपको जरूर आएगा एग्जाम में, because they have included even in textbook this type of sums. So I know beta is IC upon IB. Once I get IC IB, then IE is IB plus IC. Beta is 99 equals to IC upon 20. So IC is 291,980 microampere. IE will be 120 plus 1980 micro, that is nothing but 2000 microampere. Clear? Hello? This some any doubt? Yes, any doubt in the sum? Yes or no? कुछ डाउट है क्या सम में?
नहीं सर.
Okay. Next one, sum number 37 after this. A PNP transistor is used in common emitter mode in an amplifier circuit. Change of 40 microampere is in the base current. Delta IB is 40. Brings a change of 2 milliampere in the collector current, that is delta IC, and 0.04 is base emitter voltage. 0.04 base emitter voltage. Then what is input resistance? Input resistance R is voltage upon current. So input voltage VBE, input current is IB. Voltage is 4 into 10 raised to minus 2. Current is 40 micro, so 10 raised to minus 6 in ampere. 4 into 10 equals to R is V upon I. So this will become 10 raised to minus 2 upon 10 raised to minus 5. That is 10 raised to 3. So 1 kilo ohm. 1 kilo ohm answer. Completed 37th? Hello? Yes, completed full. अरे कुछ तो बोलो. अभी बोला है आगे. In question number 37, find the base current amplification beta. What is beta? Formula?
Alpha upon 1 minus alpha. अच्छा वो sorry.
IC upon IB. वो वाला भी राइट है, लेकिन अल्फा किधर दिया है अपने को, नहीं कर सकते.
हाँ सर हाँ.
कलेक्टर करंट कितना दिया है? 2 मिली एम्पियर ना. And base current is 40 micro. So 10 raised to minus 6 2 into 20. So this will become 10 raised to 3 upon 20. So 1000 upon 20. 20 into 50. 50. Option C, 50. 39th one. In same question, if load resistance, that is RL, is 6 kilo ohm, then what is voltage gain of the amplifier? याद है कि आपको पहले voltage gain का formula? Anybody remembers? It is output voltage upon input voltage. Output voltage is delta ICRL and input is IB into RI. This whole thing is called beta. So beta RL upon RI. Beta we got 50 in the previous sum. Load resistance is 6 kilo, so 10 raised to 3. Input resistance we got 1 kilo, I think. 1 kilo ohm. That is 10 raised to 3. So voltage gain is 300. Is the answer. Option C again. Is completed till 39. Next 40th. In NPN transistor, collector current is 10 milliampere. 90% of the electron emitted reach the collector. 90% of electron, that means of the emitter, becomes collector current is the meaning. Again, read carefully, very important word. Collector current is 10. If 90% of electron reach the emitted reaches the collector. So 90% of emitter becomes collector. Then find what is IE and find what is I. See, 90% of IE equal to IC. So 90 upon 100 of IE equals to 10 milliampere. So IE will become 10 into 100 upon 90. I will become 100 upon 9. 11.11. That I can take 11 milliampere. I is 11 milliampere. Now I is always IB plus IC. So if this is 11, IB you don't know, and IC is 10. So IB will become 1 milliampere. So 11 milliampere IE, D option. Write carefully. These all are very, very important sums. Done 48? Hello, completed 40.
Yes, sir.
Next 40. For a transistor, circuit shown below, beta is 100, voltage drop between base and emitter is 0.7, then value of collector emitter voltage will be how much? And this is the diagram given which you have to refer. Volt, 8.6 kilo ohm. This is 5 volt. This is called VBB, and this voltage is VBE between emitter and collector. Emitter and base. Base, emitter, collector. This is 100 ohm. 18 volt. Find what is VCE. Can you recollect that formula? VCC is ICRL plus VCE. याद आया ये formula? Hello? Hello?
हाँ सर.
ये formula याद आया?
हाँ.
अभी बेस एमिटर वोल्टेज दिया है, ये इनपुट रेजिस्टेंस दिया है, बीटा दिया है. So can I find IB? IB मतलब current. Input current is input voltage V upon R. Input voltage is delta VBE. Input resistance RI is connected to base. VBE बोला है 0.7 है और RI is 8.6 kilo. That means 10 raised to 3. So base current we got voltage upon resistance. Voltage is VBE. Resistance is nothing but 8.6. So current flowing will be equals to 0.7 upon 8.6 into 10 raised to 3. फर्स्ट पार्ट हो गया. अभी ये बीटा इक्वल्स टू डेल्टा आई बी अपॉन डेल्टा आई सी. Therefore IC upon IB. Beta is 100. IC we have to calculate. ये मिला 0.7 upon 8.6 into 10 raised to 3. Therefore we'll get delta IC equals to 100 into 0.7 into 10 raised to 3 by cross multiply upon 10 raised to 3 upon 8.6. Copy till IC. The actually it is Ohm's law only we are using with proper circuits. Completed till IC वाला part?
Hello, sir.
हाँ?
Sir, I might get disconnected now, sir, as my actually the Geo hotspot's battery dongle's battery has ran out. So and the and the package is also over, sir.
No
I
problem.
might disconnect in a few
No
minutes.
issue, no issue. Yes, you all got till this? Hello? Yes, done?
Yes, sir.
So VCC is, now I'm substituting here. VCC is 18. इधर तक हो गया अभी. VCC is 18. IC we got 0.7 upon 8.6 into 10 raised to 5. 10 raised to 5. And RL is 100. So 10 raised to 2. Plus VCE we have to calculate. So I feel there is some error in the values. Just write this formula. I will rectify the error because a VBE अचानक 0.7 और इसका voltage 5, there must be some mistake. शायद ये 4.7 होगा. Okay, this solution just write down as it is. I will rectify the mistake after checking where is the error. But this is the method how we are going to do. Skip 42, 43, 44 and 45. Next class we'll be doing that. Look at sum number 50, last one. 50. A, B, X are given as a truth table of some gate. You have to identify which gate it is. 0, 0, 1. 0, 1, 0. 1, 0 is 0. 1, 1, 0. Hello? हाँ बता. नाही फक्त ऑप्शन आहे. 1, 1 is 0. Now see, if you look carefully, if I just take its complement here, I get 0, 1, 1, 1. So 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1 is given for OR gate. So इसका उल्टा इधर आया, मतलब ये NOR gate है. So our option is NOR gate. NOR is given in C. 49. For a given combination of gate, here it is A, B, C, gate 1, and then its output is given to gate 2, which is NAND gate. This is NAND, clearly we can see. And this is OR. They want output. First logic gate, if A is 0, B is 0, C is 0. If A is 0, B is 0, this will be 1, 0. 0, 0, in case of NAND, it will become 1. NAND output is 1. And in second case, A equal to B equal to 1. So 1, 1 will give me output here 1. C is still 0. So 1, 0 has no output in AND. If no output in AND, here it will give you output ulta. See 0, 0 in AND, 0, 0 is 0. But in NAND, it will become 1. Same way 1 and 0 in AND it will be remaining 0, NAND it will become 1. So our outputs are 1 comma 1. 1 comma 1 गलती से दो जगह पे मार्क है, तो B and D are both options. Output of NAND gate is 0 if both the inputs are 1, because if A, B are 1, AND will be 1 and AND ka complement will become 0. So both inputs are 1, then NAND is 0. That is C option.